Myself, good morning, all of you. Myself, Professor N.V. Harpe from S&T College of Engineering and Research Center, Deoga. Uh, now, uh, now today we will discuss the new topic of numerical methods and computer programming. That is Newton's. That is interpolation. In that, the method is Newton's divided difference method for interpolation. And what is interpolation? When the number of points, the number of data, the number of values of x and y are given, and we can find out the any value of y with uh, with the with respect to x, with respect to x. Suppose given the coordinate axis x0 comma y0, x1 comma y1 up to xn comma yn, find the value of y at a value of x that is not given. Means suppose the x value is given and we can find out the values of y by using the given data, that is the given values of x and y. This is called as interpolation. The interpolation or suppose the value of x is in between x0 to xn, then it is called as interpolation. And if the values of x which is outside the range of x0 to x0 and y0, then it is called as extrapolation. It is called as extrapolation. The interpolation method, it is used for finding our most common choice. Polynomials are the most common choice of interpolants because they are easy to evaluate, differentiate and integrate. Means the Newton's divided formula or Newton's forward or Newton's backward difference formula. These all the formulas are which is used for finding the interpolation value as well as for finding the differentiation, means derivative and integration. Derivative and integration. The Newton's divided difference method. This method is used when the step size of x are different means suppose the x1, the difference between x0 and x1 and x1 and x2 both are different, then we can use the Newton divided difference method. Suppose the x0 and x1, the difference between x0 and x1 and x1 and x2, it is same, then we can say that the interval between the x coordinate are equal. So when the intervals are unequal, then we can use the Newton divided difference method. The general formula is for finding the value of f of x is equal to b0 plus b1 into x minus x0, where b0 is equal to f of x0. Then put the value of b0 in that equation, then we can find out the value of b1, that is f of x minus f of x is equal to f of x0 plus b1 into x minus x0, x1 minus x0. Then suppose f1 of x at x is equal to x1. Suppose x is equal to x1, then it is f of x1 is equal to f of x0 plus b1 into x1 minus x0, and find the b1 is f of x1 minus f of x0 divided by x1 minus x0. Suppose the upward velocity, this is a one example. Upward velocity of a rocket is given as a function of a time in a table, that is a table. Find the velocity at t is equal to 16 seconds using Newton divided difference method for linear interpolation. Means the value of 0, 10, 15, 20, 22.5 and 30. This t value is given and the velocity at that time is also given. Find the velocity at t is equal to 16. Then the formula is v of t is equal to b0 plus b1 into t minus t0. T0 is equal to 15. T0 is equal to the 16 is in between 15 to 20. Then we can also find out the values between 15 to 20. Then x0 is equal to 50, 15 and x1 is equal to 20. Then t0 is equal to 15. Then v of t0 is that is given 362.78. V of t1 that is t is equal to 20, 17.35. Then b0 is equal to 362.78. Then find out b1. b1 is equal to what? V of t1. This is 362, sorry, 517.35 minus 362.78 divided by 20 minus 15. That is 30.914. 30.914. Suppose t value, this is your, we can take t is 20, 16. At that time, this t will be taken. At t is equal to 16, v of t 16 is equal to 362.78 plus 30.914. The value of b is 30.914 into 16 minus 15. This is t is 16 minus 15. That is the velocity is at t is equal to 16. That is 393.69 meter per second. This is a quadratic interpolation. Suppose there is a three coordinate axis, three coordinate points x0, y0, x1, y1, x2, y2. Fit a quadratic interpolation through the data. That is the equation b0 plus f2 of x or f of x2 is equal to b0 plus b1 into x minus x0 plus b2 into x, x0 into x minus x1. b0 is equal to f of x0. Then f of x1 minus f of x0 divided by x1 minus x0. That is your b1. Only take only these terms first. And when for finding the b2, all the terms, put the value of b1 in that equation, and then it is b2 is equal to f of x2 minus f of x1 divided by x2 minus x1 minus f of x1 minus f of x0 divided by x1 minus x0 upon x2 minus x0. This is the same problem. We can find out the value of velocity at t is equal to 16. This is t0, t1, t2, 10, 15, 20, 227, 362, 517. Then b0 is equal to 227.04. b1 by finding that 362.78 minus 227.04 divided by 15 minus 10 is equal to 27.148. Again, find the b2. Put the values of b0, b1 and b2 in that equation and find the value of velocity at t is equal to 16. That is 392.19. In first equation, First method 393.69. In that 392.19, the relative error is 0.38%. The general form of the formula for Newton divided difference interpolation method is f of x is equal to b0 plus b1 of x minus x0 plus b2 into x minus x0 into x minus x0, where b0 is equal to f of x0, b1 is equal to f of x1 minus f of x0 divided by x1 minus x0. It is nothing but f of x1 comma x0. b2 is equal to f of x2 comma x1 comma x0, means f of x2 comma x1 minus f of x1 minus x0 divided by highest term minus lowest term, that is x2 minus x0. By writing this term, then this is the f of x is equal to f of x0 plus f of x1 comma x0 into x minus x0 plus f of x0 comma x1 x2 comma x1 comma x0 into x minus x0 into x minus x1. This is your general formula for finding the value of y at given values of x. This is a difference table, divided difference table. x0, x1, x2, x3, f of x0, f of x1, f of x2, f of x3. This is b0, this is b1, f of x1 comma x0. This is taking the difference, f of x1 minus f of x0, f of x2 minus f of x1, f of x3 minus f of x2. Again, f of x2 comma x1 minus f of x1 comma x0, that is f of x2 comma x1 comma x0. Again, similarly take the difference, and this is your divided difference table. We can find the values of b0, b1, b2 and b3 from that equation, from that table. Then we can find out the value of velocity at t is equal to 16 by using general formula. This is b0 plus b1 into t minus t0 plus to t minus t0 into t minus t1 plus b3 into t minus t0 into t minus t1 into t minus t2. Then all these values are taken t0, t1, t2, t3, 10, 15, 20, 22.5. Then b0 is equal to 227.04. b1 is equal to 27.148. The difference between that, b3 is equal to this and b3 is equal to this. This will be find from that table t0, t1, t2, t3, y0, y1, y2, y3. Again, this is b0, b1, b2, b3. This is b0 is 227.04, b1 is 27.148, b2 is 0.37660 and b3. Put the values, all the values in that equation and put t is equal to 16 and find the answer. And this is the final answer for the velocity at t is equal to 16 by using this Newton divided difference method. This is the comparison table. When the order of polynomial increases, suppose first order, the value of velocity is 392.69. At second order polynomial 392.19, the error is 0.38%. When order is increases, the error should be minimized. The error should be minimized. This is the Newton divided difference interpolation method for finding the value of y at x at the given value of x. This is the method for finding the interpolation. Thank you.